Hello, hello. I'm gonna set up my screen really quickly.
Hello? Oh, there we go. Okay. Cool. Thanks for joining. Appreciate it. Hope that you're having a decent afternoon.
Yes. Hold on. Okay. Set up the presentation. Hello, how's everyone doing here? Okay, so it's about 1. Maybe I should give it a minute or two for people to settle in. But hi, I'm Nolan, and this is my introduction to Python workshop. So without further ado, we kind of like start getting into it. So this is recorded. Anyone could kind of just go back. I put a little extra content on the slides just so you could go ahead and reference this if you ever need any Python references, etc., etc. And yeah, so here are the resources. Resources are available here through these links. So the slides are available via tinyurl.com/treasurepython. TNP are capitalized. And so we're gonna go over a few libraries, and at the end we're gonna go over my repository for LA hacks to kind of give a demo of how Python can be used in hackathons. So yeah, why should you use Python? Python is an interpreted general purpose high-level programming language. And what do we really mean by that? High level just refers to the fact that Python, it has a lot of abstractions to kind of like the system code that it runs off of. So for example, if you have like C or assembly, which are like lower level languages, you have to worry about memory management and RAM and stuff, and then you don't really get to and then after you get that sorted out, then that's when you can like start figuring out the high level concepts like data structures, etc., etc. Python, because it's so high level, it's very English friendly, user friendly, and it just allows you to do all these things without having to worry about the lower level stuff. So yeah, it's used in machine learning, software development, data science, game dev, everything, because people love the language so much and they've pushed it into so many different categories. But usually it's used in machine learning, data science, web dev. Notice how like those 3 things are like very high level concepts where you really want to build something really fast and you don't want to worry about like the low level like system stuff. There's a little bit of robotics, but like usually it's not used often in robotics like at all. I guess like people are making stuff for robotics lately. Okay, so basically, yeah, there's a massive community around this, and there's a lot of flexibility without worrying too much about the details. In hackathon, this Python is very, very frequently used for backend because it can't really do anything in front end. Because the thing is, Python is kind of slow, and that's because it has so many levels of abstraction where like it just builds so much code around like all these low level things that you don't have to worry about. So you don't really think about it. But Python is kind of slow. But it's used a lot for backend because it's just very easy to like implement APIs and stuff. Like kind of like the ChatGPT API workshop that you guys looked at earlier. If anyone went to that one. So some common stuff is MongoDB and Flask. I use Flask all the time for hackathons just to get something deployable really fast and interactive. So the way you get started is if you head to like this download link. So these are docs. Most people get started through Anaconda. Anaconda is kind of just like this platform for hosting Jupyter notebooks, and Jupyter notebooks kind of look like this. So if I open up my Anaconda, so when you have this downloaded, for sake of time, I'm not gonna go through the installation, but you could kind of just like launch one of these. You could either launch Jupyter Notebook or Jupyter Lab, which is kind of like for running Jupyter notebooks, and of course you run it in like VS Code as well. But yeah, so if I go to my Jupyter Lab, there's like this is for like my machine learning course. But basically you could kind of edit bits of code here. So like if we were to do like a print Okay, there's a server connection, probably because I restarted my computer recently, but you could kind of like run each of these code blocks in kind of to test like parts of your code before compiling a full script. So here's like an online version of it. So this is something that I was looking through earlier today, but in Jupyter Notebooks, you can kind of like write text here and you can run portions of code. So if I were to want to run like a specific code block, so like for example this, it would be able to just like only run that code section to test small sections of your code. And it's like really useful for that purpose before writing like your full .py Python script. So yeah. So going back to slideshow. So yeah, let's start with something simple and write a hello world program. So hello world in Python is really simple. You print hello world and that's it. So like if you were to look at this in assembly, yeah, it'd look like this. So you'd have to worry about all these different variables, like how much. So you see, you're setting like a variable to 4 bytes of memory or something, and then you push it and you call it and then you return it, and et cetera, et cetera. And it's like super annoying. And then there's Python. You could just print hello world, kind of like print ln hello world in Java, if you're familiar with it. And yeah, here are the basics. So Python is dynamically typed. And what do we mean by this? So dynamically typing means that it automatically assigns variables to either integers, strings, etc., without having to like actually call them. You don't have to write like string full name is equal to John Smith. Instead, you just write full name is equal to John Smith, and it'll be like, okay, that's a string. And if you could set in variables, and if you wanted to like print that data in a variable, you could just type in print and then age in parentheses. And yeah. So we have 4 different data types in Python. You have an integer. So integer is just like a number. It's a whole number. That's how you could think of it. A float is like a decimal number, and a string is a sequence of characters representing a text. So you could think of, if you're not familiar with kind of just like computer science topics. So characters are, so typically in every single programming language, strings are represented by characters, and each of these characters, they're kind of like arrays of characters. So you could think of each of these characters being like combined together, like stuck together, and that's what a string is. So a boolean is a binary value that could either be true or false. So you could think of it as like 1 or 0. And yeah, and you have your operators. So like plus equals, minus equals. So plus equals is like incrementing by a certain number. So it's like plus equals 1. So if you had like, yeah, age plus equals 1, you would add 1 to the variable age. And then you have these comparators. And here are more operators that you could like divide by. And then this percentage symbol is called modulo. So modulo is basically like returning a remainder. So yeah. So typically people use modulo to check if something's like even or odd. So like if like 2 modulo 2 is equal to 0, which means the remainder is 0. If you divide by 2, that's like an even number. And yeah, so that's how operators work in Python. And then you also have and, or, and not. So you could write this as like, if you wanted to check a condition. So like if you wanted to check if both 9 equals 10 and 6 is less than 21, then it would return like true. So that's how you could use like operators and combine them. So or would be like if one or the other is true. So like you could say like 9 equal to 10 is false here, but then 6 is less than 21, so it would return true. And then not is a negation, so you negate whatever comes after not. So it's like not false is true. And yeah. So pop quiz. What would be printed to console in these examples? So like if x is equal to 3 and then you set x decrement 2, which is minus equals 2. So what would x print out here? Can anyone give an answer? Actually, do I have to like give someone permission to talk? I'm not really sure how this
It's all
works.
good. Top right, there should be a little chat, and if you go back to Discord,
Oh, I
top
see.
top right,
Oh,
right.
okay. Top right. Yeah. One. Yep. It's just one. And then if you were to do like y equals um 9 and then y equals y divided by 2, what that print out? 4.5. Yep. And then this is kind of tricky. So z equals not 3 is less than 2 and true. So is 3 less than 2? That would be false. So false and true. And then you print out not false and true. So yeah, it should be true. Because this statement inside is false. Because false and true is false. And not false is true. Yeah. Anyway, so there's a lot of built-in functions in Python. There's stuff like, so you could, so if you had like a number and it was like an integer and then you want to turn that into like a decimal number, you would call float on it and then it would turn into like 2.0. Or if you had like, if you wanted to turn the number 2 into a string, you just type in str around it. And there's like a bunch of math stuff. So if you want to see all the functions, the entire Python documentation is in these slides. So go check it out. And yeah, there's a ton of functions here that we don't have time to cover. But to kind of like finish up the logic here, so these are how conditionals work in Python. So you have if a condition here. So if x is less than 10, then you have your colon, and then it does whatever is in here. And then else if means that. So like if if statements, if these were not else if statements, it would check every single conditional here. But then else if means that if this is false, then you do this. And then if this is false, then you keep going down the list until this, which is like else. If all of these are false, then you do this. So yeah, Python blocks its code based on indentation, not curly braces. Like if you're in Java, you put like curly braces around everything. You won't have to do that in Python. And for loops. So for loops are kind of like work like this. So for index in range, all these numbers will run the loop from 1 through 9. So like if you were to type just for index in range from 0 to 10, so it would run through the loop from 0 to 10. And while loop keeps executing as long as the current condition remains true. So while 9 plus 10 is equal to 21, which is clearly false. So this loop will never run. And break stops the loop. So it breaks out of the loop and then just keeps continuing with the code. Continue goes to the next loop of the code. And yeah, that's how these work in Python. So what do you think this code will output? So for x in range 0, 10, 2, what happens? It would just print out all the numbers by twos. So it print out kind of like it print out all the numbers in range from 0 to 10. So this parameter at the end, a lot of people don't. I guess I haven't seen a lot of beginners in Python use this. So if you're not like, if you don't use Python often, you might not see this. But this basically means like skip by 2. So it print out all the x's from 0 to 10 in twos. So yes. Here's another one, which can be quite tricky. So it's basically saying, so while y is not equal to 0, if y is even, then you print y, and then you decrement it. So it goes from 10. So if you start at 10, like the loop, 10 is not 0. So you print it out because it's even, and then you go down the list. So it'd be like 10, 8, 6, 4, 2, etc. So yeah. And yeah, there's a cool way of doing conditional statements in Python. You could use ternary operators. So instead of writing like this whole block of if-then statements, you could do this. So like number is equal to 5 and x is equal to 5 if this, else this. So you could kind of like see the structure here. This is why Python is pretty cool, because you could do a lot of things in one-liners. So yeah, the syntax for this is like, so this happens if this condition is true. If it's not true, then you do this. The only downside to this is you can't really do like elif statements here. And yeah, so, or like it's where you would have to you would have to make it much more complicated if you want to do elif statements in here. But it's really useful if you want to just like write a really fast conditional. So yeah, so you could also do something really cool in Python. So for loops. So here, this is a list. A list is like an array, so you could think of it as literally like a list of numbers. You know, you have like 1, 3, 5, 7. And if you want to like square every number in here, so 2 asterisk in Python means just like raised to power of. So this is I to power of 2. So you want to square all these numbers. Instead of writing it through this loop here, you could just write num squared is equal to this for I in numbers. So like you could see you write what happens to the variable so for each item in the list. And then here would be your check. So this is kind of like how Python operates, and you could do really fast things like this. And these are called list comprehensions. And yes, so this is kind of how we use it. So expression for item in list if conditional. So list comprehension is great for performing quick operations and filterings of a list, and it's commonly used. So you'll see this really, really often. And yeah, so when you want to write variables in a string, you're going to have to, there's a lot of different ways to do this. You could use like percentage name to refer to like this variable here. So like %s, this just means like percent string. So it'll take like the first variable here that's in percentage and just like put it in here. So it print hello Bob. Or you could use this format. But these are really annoying. And there's a cool way to format strings where you could do just f and then you put the variable name in parentheses, which is a lot simpler. In Python, there are functions. So functions, you want to have to define a variable like in Java. So like in Java, if you were to do this, this would be like void because this is printing out. If it was like returning a string, you'd have to like say string greet. And that's like super annoying. But in Python, everything is dynamically typed, so you don't need to worry about the types. So you could just write def, which is the definition. So you're defining a function. You're defining a function called greet. And you have these parentheses here, which means that if you want to take in any parameters, you can. But in this case, it doesn't. It just prints hello world. So what if we want to pass data into a function? Then you simply just make parameters in here. So like I said before, Python's dynamically typed, so you don't have to worry about where name or time is a string or an integer. So here, in this case, I mean, because you're putting it into a string here, you're printing it into a string, these have to be a string, otherwise there'd be an error. But there's a way to do this. You could just write like str around time and name. But this would be how you could like print out a string where it says like, "Good morning, David. Hope you're doing well." And if you don't want to always provide input, you could always set like default parameters where you could set equal to this. So it's basically saying like, if you don't write anything for these parameters, it will automatically set to Daniel in the afternoon. So it'd be like, "Good afternoon, Daniel." unless you write something inside. And yeah, so to return something, so you can have functions return a variable. So like define this. So you have like new number is equal to num times 3. So all print does is just like it prints something out to a console. It doesn't actually return anything. The function doesn't give any values. So in order to do that, you'd have to return it. So what happened if we were to do this? It's like print multiply by 3, 2. You just multiply this value by 3, and it would return that value. I'm not sure. If we have time based on the pace that we're going? Okay. Yeah. So, this is an exercise you could probably do in your own time. You could kind of just like look back on these slides if you need to later. But yeah. So we're gonna go through some of the content because there is like some other content that I want to cover, which is like kind of like hackathon specific, how to use Python, or like how Python is typically used in hackathons. But going on to basic data structures. So like we talked about before, we have lists and tuples. So lists, you could define them, you can make it empty, and then you can add things to the list, which is great. This is what's called mutable. So mutable in computer science is like you could change the values inside a data structure. So in this case, a data structure is something that just contains data. So here, this is a list. It contains data in this format. So it's like 3, 6, 9, 12. So you could kind of just like add and remove elements, access them based on your index. Tuples are another data structure. You can't change values. It's immutable. So that's kind of like the difference between list and tuples. If you want to think about why do you ever use a tuple over a list, so tuples, if you want to get really specific, tuples use less memory, so it's kind of like faster to use a tuple, whereas a list, it uses more memory. So that's kind of like a very, very high level description of why you'd use one or the other. And yeah, so you could append and move elements from lists with ease. This is why tons of people use lists all the time. It's like the staple data structure of Python. And sorting makes sorting lists really simple. You don't have to run a for loop through the entire list to like do like quick sort or like merge sort or some other algorithm in order to sort a list in Python. So this is very simple compared to like Java. I mean, you could import some stuff in Java to like do this, but you don't have to import anything in Python. You could just type dot sort and it'll sort the list. And you can do it for strings too. So if you have like Maggie, David, Henry, it's sorted in alphabetical order. So you don't have to like grab the library as you do in Java or like C or C++. And yeah, so, and we have another data structure. Sets are data structures that are unordered, unchangeable, and do not allow duplicate values. So all values have to be unique. So like before, like this is much faster than a list, but it's like you just can't. So you want to have your program run faster, and like so this is like really the data structure only matters when you're dealing with tons of data. So if you're dealing like with something like size of like ChatGPT level data or something, that's when you start like really worrying about like how you work with lists and et cetera, and like, well, at that point you wouldn't really use lists. You'd use like other packages that use lists, like and like sets and stuff. So like they handle it for you, and yeah. So now we move on to another data structure called dictionaries, which are a lot slower than lists, but they're like really fun to work with, or they're very very like dynamic. So they're like lists, except so you have in a dictionary, they're like a hash table, if anyone is familiar with a hash table. But basically, you can think of a dictionary as in like an actual dictionary. So when you open up your dictionary, you have a word and its definition. So here they're called keys and values. So if I were to define a dictionary called person, and its first name was Nolan, age was age is 20, major is computer science, and minors could be mathematics. So notice how this is actually a list. You could actually put like lists and our data structures inside our data structures, and what that's called is called nested. So I'm kind of like nesting a list inside this dictionary, or you could like nest a list inside of a list. Um, and yeah, so basically, if I were to like edit this, I could kind of like type. It doesn't have to just be mathematics. Maybe I could type like what's another related major? I guess cognitive science or something. And yeah, so basically, like you could just now you have all these different items in here, and then you could probably call specifically like cognitive science from this dictionary by typing in person. So when you want to get a value, you just type in the key. So so let's say like I wanted to get the key. I just type in like person and then minors and then 2, which would return cognitive science. So yeah, that's kind of how you access and update data. And this is mutable, so you could change the values in the dictionary. So like you would set the first name instead to Henry, and then like set minors to his list of only cognitive science. And when you print that out, it'll be some guy named Henry with computer science, age 20. And instead of minors of both math and cognitive science, it'll only be cognitive science. So yeah. So you could create like functions based on lists. You could kind of like do this on your own time. We could probably run through this if we have more time at the end. But yeah, classes. You honestly will never really use classes in a hackathon because you most of the time you're kind of just like worrying about a script, and kind of like yeah, there's like a lot of other stuff that you deal with where you probably don't really use classes too often. You could I personally haven't really used classes for kind of like my scripts, but they're really good to know. They're just like good coding practices if you want to like get into object-oriented programming. So every primitive type in Python that you use before belongs to class. So like if you're to type type check, so in Python you could type in type to see the type of a variable. So here you can see 13 is an integer, 16 is an integer, hello world is a string. So you can see they're all defined as classes. So data structures are essentially classes. You could think of classes as really, really big templates of data. So like just think of classes as a data structure. You're making a data structure to build something. So let's say you want to make a class for like a dog. So a dog has maybe 3 different things here. So it has breed. What type of breed is it? It could be like a beagle here. And then I guess what sound does it make? What type of bark does it have? And then it has like a speed of 5 or something. So these are what's called attributes. So basically you make a template here of like a class dog. So if you could think of it as like instead of like an integer or like a string or something, it's just a dog. So you have a dog here and you have these 3 attributes to it. So it has breed, bark, and speed. So in order to create a dog object class, you would have to do like, so if we were to define like Snoopy, it'd be a dog of beagle, type beagle. So that's its breed. So you can see this is like the first parameter here. And the second parameter would be like, what type of bark does it have? Like woof, right? So you'd kind of like type this in as if you want to kind of like define it explicitly, you could also just type in here like breed is equal to beagle. Oh yeah. So what else can you do with classes? You can make functions in classes. So if you were to, it's because you can't change like the. So if you were to want to actually like set the breed, you would change it this way. Just so you don't have to type in like Snoopy.breed is equal to, and so you just write Snoopy.setBreed, colon retriever, and then you can return things based on the attributes that the class has. And yeah, so whenever you use like whenever you make a function for each class, you have to write like self, because you're basically saying that the function does things to itself. So here it would change its breed, right? So self.breed is equal to name. And yeah. So we could take a look at how Python is used in hackathons through this. So this is kind of like an app that I wrote for LA hacks. So this is a pretty large number of packages that I used here, but if I were to kind of just like open up my here, I could check my VS Code. Let me see, what recents do I have? Okay, I'm not sure if I have my GitHub repo open or not, but basically, oh, I reset this laptop recently actually, so I don't actually have this on local. Basically, here we have kind of like our front end and our back end. So we're gonna take a look at my front end for this project. So the dev post is, we could probably just like look at the example through a dev post here.
Quick question from the chat.
Yeah,
Someone asked, what Python IDE would you recommend using?
I would actually recommend using VS Code. I use VS Code all the time to kind of just like write scripts and do things. So usually I use Anaconda. So Anaconda Navigator. Let me restart my Anaconda. I think it's having some issues. So okay. So my workflow is kind of like, okay, I develop things in Anaconda and test kind of like code blocks to make sure everything is working, and then I write like a full script like this app.py app that I have. So if I go to my backend, so this would kind of just be the full script. But before this, I actually had to run and test a lot of these different sections here. Oh, okay. Actually, I do have a local. Let me see. Okay, I'm still getting a server connection error for some reason. So, okay, bear with me. Let me see if I could kind of just like open folder. Okay. So this is kind of like my project here. There's a lot of files. There's a lot of things to look at, but let's ignore all this and kind of only look at the app.py. So usually, I would have this actually running in a Jupyter notebook, because Jupyter just lets you look at all this a lot more easily. But you can also just have it running in VS Code as well, just like on 2 tabs. So let's see here. So I would kind of just like run through a script and test various different parts. So here I was looking through, I was doing like data analysis and testing how OpenAI's API would work here. Okay, I'm gonna have to probably regenerate a different key because my key got leaked. So it's okay. It's okay. Anyway, so I run kind of like separate code blocks in here, and then I translate a lot of this code over. So this is kind of like my sandbox for running a lot of my And I translate that to a full script here, where I actually just like, usually Jupyter Notebooks are really good for testing because you could generate visuals here. So you could generate graphs like what I did here. This is kind of like generated from a package from an API that would kind of like try to predict different locations in text. So the purpose of my last hackathon project was to extract locations from YouTube videos. So it's like Shazam, but for YouTube videos, and you get locations. So we had kind of like a front end, and they connect to our back end. So kind of our demo here would be like, I'm gonna mute one of my teammates. Basically, you'd go through this. So this is our front page, which is like Wayfair. You'd fetch a YouTube video, plug it in, and what this would do is it send requests to our backend, which is managed by Python. So after it finishes loading, it'll generate all these things. So most of these are generated by Python, and then it's translated over to our front end. And to do that, you could use something like Flask or a database. Like, so the main two that I see most people using at hackathons is MongoDB and Flask. So what I usually use is I run Flask because it's really quick to deploy. You just write a flask.py app and you just import Flask. You import a few things from Flask, and you could just do at app route. So what app route does is it creates this creates like a route. So you can think of it as you're making a route from your back end to your front end. So it's sending whatever happens in so like it's making a connection between this function and something else in our front end. So in our front end, in our I believe it'd be in our source. I was a backend dev, so I'm not entirely familiar with this, but basically you would kind of just like do something very similar in your front end to connect it to your back end. Usually, so an ideal hackathon team is kind of just like 2 backend devs and 2 front end devs for like a team of 4. And then you kind of just like relay, okay, I have like this function written in this script. Can you set up something in the front end that connect to my back end here? And our team was like really well organized because we had the like ideal combination, so we were able to just like get this going really quickly. So yeah, essentially this would import all these different libraries. You can see like there's like a little bit of everything that we use that we discussed in the slides here. So this is kind of just like adding to text line. And yeah, that's pretty much it. So does anyone have like any questions or anything you want to like ask about Python in general? Because I'm assuming like a lot of you guys here are pretty new.
Yeah, so just feel free to shoot any questions into the chat. Or if you want to come up on stage, that's cool too. But in any case, we can just hang here for a little bit, but we can just do like some random questions in the meantime if you're cool with that. Unless everyone is good.
You kind of like run things in a book. So you could run code step by step. So the benefits of Jupyter Notebook is that you could also just like it's non-linear. So if I were to define a code block here, which was like x is equal to y or x is equal to 1, it would set x equal to 1. But if I were to like do a code block x is equal to 2, and if I were to print x up here, it prints the order that you run your code blocks. And yeah, So honestly, like, um, if you need help like with general Python syntax, like, I'm not gonna lie, ChatGPT is here. So like, there's like a lot more ease of kind of just like documentation, but I think because Python is like a more like high level language, um, the real challenge in working with Python, especially during hackathons, is kind of getting everything to kind of just like work together. What ChatGPT is really bad at is like it's really good at giving out like templates and general answers, kind of like syntax and how you kind of like maybe if you have like an error in your code, you could probably copy and paste your code and be like, okay, I have this error. Can you try to guess like what's happening? And you'll probably get it right maybe around like 30% of the time. Real challenge of working with Python is really because it's such a high level language. Most of the issues that you'll have with Python after you get syntax down is going to be like logic and how you get everything working together. Because here we have a fairly small to medium sized code base. There's like a lot of different files that we have to work with here. And we had to get kind of like our scripts working with everything, right? So you have all these like different files, etc., etc. And Python's really nice at working with these because you don't have to worry about a lot of extra lines of code. And you could just get whatever you want working really fast, albeit a little slower than if you were to have it run in our languages. Yep. Notebooks? No, it's literally you could just kind of just like install Anaconda. And you could just make a IPYNB file and get things started really fast. So like Anaconda, usually this would work, but I think there's probably some sort of issue with local hosting that I'm having here. So it's like not running properly. But you could also just have the notebook running inside of VS Code. So when you open up the IPYNB file, you could actually just make an IPYNB file through a site called Google Colab. So you have collab.research.google, and you could just make a I could just bring up a YouTube scraper I built. So you could kind of just like you could also run notebooks online. So here's this a cloud-based server. This is for free, hosted by Google. There's a lot of customizations on the site. Like you can see, I have like a dog just running across my screen here. But you could download if you're to download because you don't really have like a way to make an IPYN and B file. So you could kind of just like download a notebook here, and then you continue editing it inside of here. So you could get started. It's down to your preference whether you want to use VS Code or Jupyter Notebooks, but I find that Jupyter Notebooks are typically a lot faster. Low key, the notebooks in VS Code feel a little bit laggy sometimes. Um, and yeah. Yeah. So the great thing about Anaconda is that it'll also automatically install like a lot of necessary packages too. I mean, you should probably have Python installed. So like Anaconda will automatically detect all the things that you don't have installed, and through installation, it'll just like download everything. Um, and yeah,
Alrighty. Thank you so much, Nolan. Really appreciate
yep.
you coming out here, and it seems like the chat and the audience did as well.
Mhm.
I
Yeah.
liked all the little memes, but yeah.
Uh-huh. For sure.
Let's see. Well, in any case, we'll be posting the recording of this workshop, and if you want, you can, if you can send me the slide deck as well, Nolan, I can post
Mm.
that.
Oh yeah, for
And
sure.
yeah, just for them to reference anytime that they
Yeah,
want.
there's a lot of code here that you could probably reference and look through. Um, Here, I'll just copy the link. Or actually, I had it. It's
As a
saved.
tiny
I
URL
could just
stub.
send that. Yeah, I could send it in chat here if anyone wants to look at it.
Cool. Alrighty. Thank you.
All right, I'll be
Much
hanging
love
out.
from the Trigger X community.